Here's an example of graphing a inverse function given the original function. And there's a few techniques that books like to use. One of them is putting in the line y equals x, which is this line that goes 45 degrees right through the origin, and reflect the graph over it. A lot of people don't have good visual abilities to see what the result would be. So one of the tricks I like playing is just find a few points on this graph, just make them up, like one here, and this one here, and maybe this one, and then just a couple of them, and then just kind of make up coordinates for them. They don't even have to be precise. For instance, there could be no numbers or grid here, and you can still draw a decent graph of what an inverse should be. So this coordinate down here would be, I'm going to put them off to the side here, I would say -6, -2. This coordinate here is 0, -1. This one here, maybe 2, 0. It doesn't have to be perfect. This one here, 4, 3. And lastly, this would be 5, 6. And since an inverse function reverses the domain and range literally, all we're going to do is switch all these domains and ranges. So this -6, -2 would become -2, -6. 0, -1 would become -1, 0. Oh, why does it keep doing that? 2, 0 would become 0, 2. 4, 3 would become 3, 4. And 5, 6 would become 6, 5. And then just plot these points. So we have -2, -6 would be down here. -1, 0 would be here. 0, 2 would be here. 3, 4, 3, 4 would be here. Oh, no, not there. One higher. 3, 4. And 6, 5 would be 6, and then only 5 up, which would be right here. The curvature, this one is considered concave up, like if you held your hand underneath it, would basically hold a little bit of water. This one would spill it out. It's called concave down. When you're doing an inverse, concavity also switches. So we're going to get a graph that looks something like this. And this orange graph would be a good representation of f inverse of x, where the blue one, of course, is the original f of x. And there would be our inverse function. And this trick usually works pretty well all the time.